Good morning, everyone. Today you guys are going to read Chapter 7, Lesson 2, starts on page 242. We are going to read about different forms of energy, and you guys are going to answer the questions in the book. So grab your highlighter, grab your pencil, and let's get started. We've been talking about potential and kinetic energy. So now we're going to talk about how different forms of energy can fall into those two different categories. So let's go ahead and grab our books, turn to page 242, and talk about how we have different forms of potential and different forms of kinetic energy. All right, let's go. We're a little upside down. There we go. All righty. So during this lesson, we are going to unlock some big questions, and those big questions are, how can you find an object's mechanical energy, and what are other forms of energy? So let's start out with, I'm going to change up, there we go, the My Planet Diary. Let me take this stuff off the screen. The My Planet Diary starts out, this was posted by Lauren, who lives in Carlisle, Massachusetts. Says the first hurricane that I ever saw was a big one. The storm had weakened by the time it arrived in Massachusetts, but the wind was still so powerful. It easily flung around our lawn chairs. The trees bent and swayed in the wind. When it was over, branches were scattered across our lawn. The wind even ripped up a tree, blocking our road. The storm did a lot of damage, but we were lucky to be safe inside while watching the awesome force of nature. It says write down your answer to the question. What is some evidence that the storm Lauren described had energy? So what is some evidence of energy that Lauren described? So pause the video, answer the question, unpause it when you're done. How can you find an object's energy? Mechanical energy. Or how can you find an object's mechanical energy? I said that weird. What do a falling basketball, a moving car, and a trophy on a shelf all have in common? They all have mechanical energy. The form of energy associated with motion, position, or shape of an object is called mechanical energy. I want you to highlight that. We're going to talk about how to calculate that. So calculating mechanical energy. An object's mechanical energy is a combination of potential and kinetic. Highlight that. This is kind of hard to see, so it's almost like you're coloring in the letters, kind of. For example, the basketball in figure 1 has both potential and kinetic energy. The higher the basketball moves, the greater the potential energy, because remember, it has that gravitational potential energy. The faster the basketball moves, the greater the kinetic energy. You can find an object's mechanical energy by adding together the object's kinetic and potential energy. So highlight, usually we would circle, but because we're on a black paper, you can't really circle, so I want you to highlight the formula for mechanical energy. Sometimes an object's mechanical energy is its kinetic energy or potential energy only. A car moving along a flat road has only kinetic energy. A trophy sitting on a shelf has gravitational potential energy only. Both have mechanical energy. So let's do figure 1. It says the basketball has mechanical energy because of its speed and position above the ground. Solve for the mechanical energy of the basketball at point A and point B. So use this formula and do this problem and this problem. And then draw conclusions. Why does the basketball's gravitational potential energy increase from point A to point B? Do that problem. Pause the video, answer those questions, unpause it, and continue on. Mechanical energy and work. An object with mechanical energy can do work on another object. In fact, you can think of mechanical energy, like all forms of energy, as the ability to do work. So you can think of mechanical energy, like all forms of energy, as the ability to do work. For example, a basketball does work on the net as it falls through the hoop. The net moves as the result. The more mechanical energy an object has, the more work it can do. I want you to try the apply it. The bowling ball does work on the pins when it hits them. Why is the bowling ball able to do work? Number 2, how should you throw the ball to maximize the amount of work it does on the pins? And then you can skip this challenge question. So pause the video, answer those questions, and then unpause it and continue on. What are other forms of energy? So far, you have read about energy that involves motion, position, or shape of an object. But an object can have other forms of kinetic and potential energy. These forms are associated with particles that make up objects. These particles are far too small to see by the naked eye. Forms of energy associated with particles of an object include nuclear, thermal, electric, electromagnetic, and chemical. So first, let's talk about nuclear energy. All objects are made up of particles called atoms. I want you to highlight that. That's important to remember. The region in the center of an atom is called the nucleus. A type of potential energy is called nuclear energy, is stored in the nucleus of the atom. Nuclear energy is released during a nuclear reaction. One kind of nuclear reaction is known as nuclear fission, and this occurs when a nucleus splits. So this occurs when a nuclear splits. A nuclear power plant, like the one shown in Figure 2, uses nuclear fission reactions to produce electricity. Another kind of reaction, known as nuclear fusion, occurs when the nuclei of atoms fuse or join together. Nuclear fusion reactions occur constantly in the sun, releasing huge amounts of energy. Only a tiny portion of the energy reaches the earth as heat and light. Okay, so nuclear fission happens when the nucleus splits apart. Fusion happens when they fuse together. I want you guys to do the Venn diagram, so use the Venn diagram to compare and contrast fission and fusion. And then what do they both have in common? Thermal energy. The particles that make up objects are constantly in motion. This means they have kinetic energy. These particles are arranged in specific ways in different objects. So they have potential energy. The total kinetic and potential energy of objects is also called thermal energy. The higher the temperature of an object, the more thermal energy the object has. I want you to highlight that. For example, suppose you have let's rewind. For example, suppose you heat a pot of water. As heat is applied to the water, the particles of the water move faster on average. The faster the particles move, the greater their kinetic energy and the higher the temperature. Therefore, a pot of water at 75 degrees Celsius, for example, has more thermal energy than the same amount of water at 30 degrees Celsius. Electrical energy. When you receive a shock from a metal doorknob, you experience electrical energy. The energy of electric charges is electrical energy. Depending on whether the charges are moving or stored, electrical energy is a form of kinetic or potential energy. Highlight that. Lighting is a form of electrical energy. You rely on electrical energy from batteries or electrical lines to run devices such as computers, handheld games, digital audio players. Electromagnetic energy. The light you see is one type of electromagnetic energy. So electromagnetic energy is a form of energy that travels through space in waves. The source of these waves is vibrating electric charges. The waves do not require a medium, so they can travel through a vacuum or empty space. This is why you see the sun and stars. So a medium is like something they need to travel through. The microwaves you use to cook the food and the X-rays doctors use to examine patients are a type of electromagnetic energy. Other forms of electromagnetic energy include ultraviolet rays, infrared or heat waves, and radio waves. Cell phones send and receive messages uses microwaves. Then lastly, we have chemical energy. Chemical energy is in the foods you eat, in the matches you use to light a candle, and even the cells in your body. Chemical energy is potential energy stored in chemical bonds. Chemical bonds are what hold atoms together. Often when these bonds are broken, the stored energy is released. For example, bonds are broken in your cells and release energy for your body to use. All right, I want you to answer this last question over here. And it says, forms of energy. Many objects in the restaurant have more than one form of energy. It says, circle 3 objects. Describe 2 forms of energy each object has. So go ahead, take a minute, do that. When you're done with that, you're done for the day. That's all you had to do today. So make sure you answer the questions that I asked you to answer. If you are a full remote student, upload your answers to Google Classroom. If you are a cohort B student, you're reading this on Thursday. I will check these tomorrow in class. If you're a cohort A student, you're doing this on Friday. I will check this Monday in class. All right, I hope you guys have a great day. Thanks, bye.